Okay, hello students. Here I am want to solve practice problem for lesson number 4.1, combining 4.1, that's exponential, and 4 pointer is logarithmic function, right? So this was done in the previous video, and this video I'll do 4.3 and 4.4, which will be more of logarithmic function. So let me continue. Now, the very first problem, let's see, is basic fundamentals of logarithm. So what is given is convert. You're supposed to convert the following to logarithmic form. So you're given 8 raised to 3. It means you're multiplying 8, 8, 8 3 times to go to give 512. So all that means is it means if x if sorry if this is the base b raised to, so this is like a kind of a function which is y is 8 raised to x. So the graph of y equals 8 raised to 3x. Of course, when I put x equals 0, it will be 1, right? So it has to go to this point. And 8 is a quite a big number, so it will be very steep, and the graph of the exponential form will be something like this. See? So so if I put 8 raised to 3 is 512. That means I'll just try to write this is, so when is it going to be, so so the question is, I want you to write it in the logarithmic form. What it means is 512. So where is 512, the point? So let's see, this is kind of, I'll just take it like a 512. Just imagine, I'm just imagining that this is 3. So the 3 is 512. So we want to write the inverse function now. We want to do going, how does 500 go gives back to 3? So it's like another function here. So if this is 0, 1, so this will be maybe 1, 0 here. So this will be reflection here, and this 512, 3, 512. So somewhere here will be 512 will be, now this is not perfectly done, but something like this. So you have something like this. So so there is a reflection. So the red graph is the reflection of the black graph. So there is a line y equals x, and you can see this point now becomes 512 and 3. And that's why we use the logarithmics. The mathematicians said, okay, logarithm of the input, which is 512, and to the base, this is 8, so the base is 8, and that is sorry, this is 3, right? 3, correct. That is 3. So in other words, what whatever the exponential form is, this 8 raised to 3 is 512, is same as writing logarithm of 512 to the base 8 is 3. In other words, all that means is when you write this form, it only means 8 when you multiply 3 times gives you this 512. That's all it is. So even though the question was very simple, I just try to explain to you what is the meaning of this is. It's like when the input is 3, the output is 512. But when you write in the logarithm, it is just a new function. It's like when the 3 goes to 512, that's what the main function 8 raised to x. But the logarithm function, log function, whatever that is x to the base 8. This one is where takes anything that is given this side, it gives back here. And that's what the logarithmic is. I only hope that. Let me do another one. Okay, here, convert the following exponential form. They give you, so logarithm. Now, main thing is the 8, which I'll use as a black color. Sorry, this 8 is important, which is the base. And now this time they give you the 64 is the red. Let's see, 64. And let's put this as the blue color. So blue color, right? So what does this basically means? What does logarithm does is how many times, it's like asking. Log basically means how many times do you multiply the base 8 to get to 44. That's all. Sorry, 64. Get to 64. That's all it means. So when you put this, it means how many, this basically means how many times do you multiply. So this is, so how many times do you multiply the 8 to get to 6? So this is how many times do you multiply to get to 60. It means how many 8s do I multiply? 8, 8, 8, 8. How many of this you multiply to get to 64? And that's why we say, okay, answer is 2. Of course, it is 2. So you don't need this. So it is just 2 of them. And that's why this is same as writing. This whole thing now is same as writing 8 raised whatever the base. So if the base is given, black color, so I'll write, okay, this 8, when you multiply 2 times, the answer gives the red 64. So that's all that means. So this is called logarithmic form, and this is called exponential form. So even though this was a simple question from my side, I just thought of you to understand what does basically this means. Uh, if I Simple example, if I write 2 raised to 3 is 8, and we write, okay, the base is 2, so I'll put a logarithm to the base 2 of this 8 is the 3. This is all that means. If I write 2 raised to 4 is 16, I just write logarithmic of base is 2, so 2, and the answer is given 16. So this is the output. So the output is become the input here, 16. See, and the input which is here, that becomes the output. That's all you remember. See, this is so simple to understand. If I write 2 raised to minus 1, we know it is going to be half, because that's how the inverse 2 raised to minus, what does this mean? Is inverse of 2, which is the reciprocal of 2. Because this itself is 2 over 1 becomes 1 over 2. So that's why we can write now, if I want to write this in the exponential form, this part. So how do I write this in the exponential form is a logarithm, and the base is this 2 which goes down, and the output is half. So this is the input, and the answer is minus 1. The input becomes minus. That's all this means. Look at the denominator is 2 here. See? So the denominator is 2. That's why I put minus 1. If the same thing was 2, then you would say plus 1, because 2 raised to 1 is 2. So it depends on the situation. Let's move on. Okay, what's the difference between log exponentials? That means if this is the exponential, y is, let's say, 2 raised to x. It means it is the graph something like this. So let me use the color for that, and I'll be using red color. So let's say this is the graph of exponential function. So that means it goes to almost touching the x. So there's a horizontal asymptote here. Y equals 0 here. So we need to know this graph, right? Y equals 2 raised to, we do know that 0 will go to 1. So I can make a table like this, 2 raised to 0. If I put 1, 2 raised to 1 is 2. If I put 2, 2 raised to 2 is 4. If I put 3, it becomes 2 raised to 2 raised 2 multiply 3 itself 3 times gives you 8. So the logarithmic function, so the log function, logarithmic of 2 to the base x like this, and so that becomes 1 becomes 0. So this will be 1 becomes 0. Then if it is 2 here, this becomes 2 becomes 1. If it 2 is 4, 4 becomes 2, and 8 becomes 3. So let's graph this. Means 0 0 is 1. This is the point. If it is 1, it is 2. So this is 2. If it is 2, it is 4. If it is 4, it is 8. So the graph is, even though I did not do it right anyway, so this is the graph of of exponential functions. So these are the points. And then now I have to reflect, I have to graph the inverse. So 1 is 0, so that's the point. Then 2 is 1, so 2 is 1. 4 is 2, so 4 is 2. And 8 is 3. And the graph this time, see, so it is like this reflection. Of course, you can do the Desmos and see the whole graph. So basically, the exponential, this is reflection over the line y equals. So this is the y equals x. The red one, which is logarithm of x to the base 2. So what I'm trying to show is this is basically the main graph. So exponential, you always should be looking. This is so all you remember is that this is the exponential graph. Now it all depends on what is the base that is given to you. So suppose I have logarithm to the base of, let's see if it is 3. Okay, so if it is 3, then it will go downwards. That means that means remember when you talk about exponential function, if this was 2 raised to x, so 3 raised to x goes faster, increases faster. That means when you try to reflect this, then it goes below like this. It goes this way, and it goes through this point and then goes little down this way. So the more the base, the higher the base, the log flattens. So that's all you remember. So the higher the base is, mean logarithm of, let's say put 4, or logarithm of 5, or log of 6, or log of 10, which is a Neperian logarithm. This is called Neperian logarithm. So this is how they will flatten like this. They go like this. So the whole idea here is, so if you see the main graph, let's see, if I want to know the original function, what is logarithm of? This is the parent graph. This is the parent graph of logarithm function to the base 2. Okay, so the main graph, that means remember logarithm of x. So logarithm of 1 to the base 2 is 0, because the reason is log of 1 is always 0, because why? Because there is a reason. Why is this answer? Because 2 raised to 0 is 1. That's why we say log of 1. So it has to go like this. So it goes. So that's the x-intercept. So to know the x-intercept, that means we always have to put whatever the input, the whole parenthesis will have to be put equal to 1 and figure out. So this becomes the main point. And there's also is, when you talk about logarithm of x, you cannot have x equals negative. So x has to be this x, which it has to be positive. So the question is why you cannot have logarithm of, let's say, 2 log of, let's say, minus whatever, minus 4. Let's see why this is stupid. Is because can you, let's see if there is an answer like this, and whatever the answer, let's call it as p. That means by definition, the exponential is 2 raised to p is negative 4. But we do know that whenever it is like the exponential function y equals 2 raised to x, the graph is something like this. So it's always above the x-axis. So it is above the x-axis. That means the range is from 0 to plus infinity. So the answer is always, so the output or the y is always uh, belongs to the real number plus. So no 0 there. So that means you cannot have a minus 4. So this itself is wrong. That means log of negative is undefined. So this is one to be taken note of, even though I'm taking some time here to show this. Okay, so hope this is understood that you can't have negatives. The main graph is, it means, it means what? What does that mean? The parenthesis x, right? It has to be, it cannot be 0 also. It means, because we have seen the 2 raised to x, the range is 0 to plus infinity. So when you talk about logarithm of x to the base 2, you have to start with the range here becomes the domain for this logarithmic function. And that's why this x has to be greater. That means x equals to 0 is becomes the vertical asymptote. Vertical asymptote. What is that means? Basically means is that means I have to draw a dotted line here. So there is a dotted line right here. So this the y-axis. What is x equals 0 basically means the y-axis. So when you say x equal to 0, it is the equation of y-axis. It is the line of y-axis. That means the graph, remember this part I did. What about I can take one more also. What about if I say logarithm of, because the base is 2, log to the base. And when do you get the answer is 1? Remember, the answer will be 1 provided the base is, if this is 2, this also has to be 2. Because that's the only way you can say this 2, base raised to 1 is 2. So that means whenever these things are same, then the answer is 1. So you got to know when is this becoming equal to, so when is this going to be 1? And only thing is this x has to be 2. So it is 2 comma 1. So the point is if this is 2, this is 1. So this also is one of the point. So the graph of this will be, so the graph of this will be like this. It has to go like this. Okay. This is the graph of the exponential, the logarithmic function log x. So this is this graph. And now based on this, we need to figure out the other graph. So all you do is very simple, which we did for square root function. So let's start with the first one. The first one says, what is minus? Look at it, this means minus, right? This is a new function. This was minus. It means whatever this function that you see here, you have to do the opposite. It means if this is 2 and 1, that means that becomes uh, 2 minus 1. So the output becomes minus 1. So this becomes, so this is 2. So this becomes the point. So this is the reflection. And that's why the graph will be reflection over the, because of this minus. Remember, if f of x is the original function, minus of f of x is always reflection over x-axis. That means I have to graph uh, the reflection of the pink one, something like this. See, so I have to graph the reflection this way. So the graph has to be this one. See? So this is logarithm of minus x to the base 2. I hope I make it. Then let's understand another one, easy one. Let's do this two. This one is there's a x changes to some from here. What change do you see is the input is done the opposite. So when input is done the opposite means it is the reflection over the y-axis. If this is the point here, this point will go 2 is 1, so this become minus 2 and 1. This point will go this side, and this point will go this side. See, it's going to reflect this way. So that means the new graph, I'm going to use the red color to show that it's going to be something like this. See, that's how the, so reflection of, it doesn't look good. Let me use, so like this. See? And that's the reflection of the pink color over the y-axis, and that's the graph. This graph will look like. But what is the meaning of this? Let me clean this everything. Too much of stuff here. So there are two things. What does this basically means? The original function is log to x. Is this part? Look at this thing. What does this thing means? It is reflect first. So this means first you reflect over the y-axis. So that means the pink color becomes the red color. Okay, so I'm gonna clean this part. So first you reflect. Okay, so you can see the graph. First you reflect. That's what I did here. First, then there is a minus. So after that, so this is reflection over the axis, and then you reflect over the axis. So the red color that you see now, you have to reflect over the over the x-axis. This point will go right here. This point will remain. That means the graph will go something like this. So this will be the graph of minus log. So it means two reflections are happening. Reflect over the y-axis first, and then reflects over the x-axis. I hope I'm making sense. So that should clarify question number 2. Let's go question number 3. Yeah, so let's see. One thing is, there is one way to do is, okay, you just write this in the exponential form. So let me write this is given to use this way to the base 3. Let me write nice and big. We have a lot of room there. So let me write up here, there. So take this off and right here. So logarithm of, I like to put a long G, even though when you type it, you won't get it. Like I'll just put 3 here, and then they will put parentheses x. So what this is negative for, right? So the input, so remember this is the input and this is the output. So when you write in the exponential form, all you do is start with the base. So the base is the 3 here. So that's 3. So I'll write 3 and this 3, or you can think of it like this kind of form. See this, you push this to, so what does 3 does? It pushes this minus 4 up there as an exponent. So this is negative 4 goes up here. See, so this input, sorry, this output that you see here, it goes as the input here. So please remember. And the answer now is you go this x. See how you go? So you start from here, always the base. You start from the base, push this up, and whatever you get is x. So that's all it is, x. So that's all you're supposed to figure out. Now you're back to your basics algebra, and this can be written as, because of this minus, it means this is 3 over 1. It means it is 1 over 3 raised to 4. And that means it is 1 third, 1 third, 1 third, 1 third. You multiply 4 times. You get 1 over 81. You're done. See? That means the answer x is 1 over 81. And the question is there a way out we can do also directly without getting into all these so many steps? But still, you need to write the step. I'm just trying to show you the shortcut as how do you go about. Just imagine if this was missing here, right? So, so what is the definition of logarithm is, so how many times this 3 is multiplied? So 3 multiply x times. So it's like 3 is multiply x times. So what is the definition of logarithm? Is logarithm basically means asking a question, how many times, my hand is paining. How many times do you multiply? Do you multiply the base to itself to give x. That's what that means. But they gave you already the answer. So it's like he's saying, okay, you 3 multiply itself 4 times that. So it means 3 times 3 times 3 times 3 is already given to you x, whatever the x there. Or it says, so that would be your 81 here, if that was the case, if it was. But right now it's not plus, it's minus. So you have to be careful. And because this is minus, you have to ask how many times do you multiply 3. So they gave you 3 multiplies. Because of this minus, you don't say 3 multiply itself to get x, but you say how many times do you multiply 1 third. That means They already gave you the 4, but because of this minus, you do one third, one third, one third, and 4 times. And that's how that gives you the answer 81. So remember the trick. Again, I repeat, just a fast, quick review, but you're supposed to write all the steps there. The trick is like this. If there is a number positive, let's see if it was, let's put it like a 81. So not 81, 5. Let's put it like a 5. There was a positive 5 here. So what is x now? So if you want to know x, means he's already saying 3. What does this mean? 3 multiplies 5, multiply itself 5 times. 3 multiplies 5 times gives you x. And you know this answer will be, this is 81, and you multiply another one, it will give you 243. But if the same was minus 5, how the changes, then you what you do is you're just asking, you just multiply the reciprocal of the base, which is 3. This is 3. So you just do one third, one third, one third, one third, and one third. So, and that will give you the answer for this if it is minus. So I hope that takes care. Let's move on to the next question, number 4. I think I forgot to answer the second one. So what is the second one is, I think you get a hang of it now. It means logarithm of base is 5 and 25 equals what? So what does log means is, how many 5s do you multiply? How many 5 do you multiply like this to get to 25? That's all this means. How many 5s do you multiply to get to 25? And you can see that 5 times 5, this itself is enough, and you don't need anything beyond this. So this 5 times 5, that means you're multiplying two of them. So 1 and 2. So the answer is 2. You're done. But while showing the steps, you're supposed to write, change this in the exponential. So not always is going to be so simple sometimes. So you need to use this base. Remember the shortcut, this is the base. Push this up, that is x, and then say, okay, and the input was 25 here, and now it becomes 25. See? And then you can write this as the black 5 raised to x equals, and this 5 can be written as 5 squared. Now the bases are the same. So if the bases are the same, it's like if I have, if a raised to m equals a raised to n, that means all this means is this m has to be equal to n. That's all it means. So you have the same bases, so your x has to be 2. So that this x becomes equal to 2. Done. So these are just the 3 problems I did, and it took me so much time. I don't know why, because it has a lot of fundamentals to be remembered. So I'll just stop this for this video, and I will continue the 4th problem in the, I think 4th problem, I forgot which problem we are doing. I think 4th only. Let me check. Yes, that was 3 questions. So just finished 3 questions. I will continue in the next video with 4.3, 4.4, 4.3, 4.4 with problem number 4.